Hi. So this video is going to cover the direction that we're taking with part two of this curriculum. Part one being 3D dev, part two being VR dev for the high school teachers, particularly for Seattle, Washington, and Elizabeth, New Jersey. The 3D dev part follows a class very specifically because the Elizabeth teachers are in agreement with our university, NJIT, New Jersey Institute of Technology, that they'll get credit into one of our sophomore level classes, IT 201 Information Design Techniques. And I put this little paragraph here because we went through a workshop kind of mid to late summer of 2019, and the ramp up for just 3D development was a lot just for the teachers to absorb. And so, since the VR development aspect, they don't have to follow as hard, and there's more tangent areas they can go down if it's more design or graphics or 3D or 360 video, or even more of a development angle. That the goal for the part two is more to get the high school teachers up and acclimated in all the most useful areas of VR dev that we talked about. So anyway, this video is just kind of an introduction. That part two is a little bit looser than part one, where part one is focused more on the students, and it's a very defined area, which is this foundations of 3D development before you move into VR or AR development. And this part, VR, is more about how to get the teachers up and going for this coming year, and then as they kind of experiment, because it doesn't seem like they're going to get their equipment up and going toward the end of the academic year anyway. Most of this new class, this new high school computer science class, will be focused on 3D development in Unity. Then maybe later on this year, maybe around winter or something, we can reconvene, see how things are going, see what additional training they need, and over the coming year, we can add more defined content. But our plan for this summer anyway is let's talk about some of the first stepping points into VR. And so anyway, I'm right here on part two, VR dev. Here's a little paragraph kind of describing where we thought we'd get to right now. This is still a definition of what the VR class will be like, and on our end, anyway, we're accrediting this, and it's going to be in our catalog. And once we run it a few times, get it more defined as we did with the 3D development class, we'll create a more defined section of classes. But there's still a code base and a lecture series connected to it. So the code base is going to be here, GitHub. This is this kind of CS app that we're making for the Quest. It's right now there's level one is binary math, and teaching binary math to like middle school, high school students, and then level two will move to some type of sorting algorithm. But I thought that this was a good project to look at because what you're currently seeing right here in Unity is a low fidelity prototype. So we used ProBuilder in Unity. It's a very quick 3D modeling plugin. It's more meant for level prototyping. And if you wish to refine these, you would go into some third-party 3D content package like a Max, Maya, Cinema 4D, Houdini, Blender. But when you start with this ideation phase, this initial concept of what this VR experience is going to be, this is actually a great way to get these ideas out and tested without investing in having these long cycle times with creating more refined content. So what you see right here is kind of this low fidelity prototype. It's just solid. It's just primitives, cylinders, cubes, spheres, which we dealt with a lot in the 3D development class, but we did a little bit of refinement or modeling work. So I think this is really good. And you see there's some textures, some different colors, some basic kind of repeatable textures here. At this stage, everything worked well. We have our interactives like levers and buttons. We have user interfaces having to deal with text and world space. So there's a lot of material to cover right here that doesn't give us the overhead of having to deal with find assets, workflows, and also this is kind of how you would want to train your students anyways, is this type of prototyping workflow to refine your UX design. And we actually did take this out. There's a completed level dealing with binary math, dealing with bits. I think the number station over here does a good job of explaining it. So each lever is a bit. We have 3 bits, so they can be zeros or ones. And this is the mapping or a little legend that for these bits. So this one can be either a 0 or a 1. This can be a 0 or a 2. This can be a 0 or a 4. And then the way that you can turn them on and off, you basically add them up and you get a total. And so we're giving little tasks to the users. Give me 3 red spheres. So you have to use a number station to create a 3. Use a shape station, and here's a little legend. Now we're moving off a direct translation to numbers. We have 2 levers or 2 bits that can create a shape, or we have a legend of 4 objects or conditions that we can represent. So if we want a sphere, we would pull this right lever to make it a 1 and leave this lever in 0. And here's our color station. So if the task is 3 red spheres, now we have to figure out, well, what's 4 is red, so what's 4? And I have to think back to the number station. So this is last because it's hardest. So first, the numbers is the most direct transference of the knowledge. Then we abstracted a bit away from numbers into like a list of shapes, but it's only 2 bits as opposed to 3. So hopefully that abstraction of knowledge at an easier level carries over, and then we make it a little bit more complicated. And can you remember what the number station is teaching you and map it to a color? And then eventually, when you put all 3 together, you go to the output station, you check what it is that you're producing against what it is that you're asked for. I should actually have started that. We have a task station that gives you a task. And then you bring the output from the output station to the task station. So anyway, this involves this idea of user experience design in virtual reality. It involves this idea of user interfaces out in the world. So we're pulling off of screen space. It makes things a little bit harder. We have to deal with text in 3D. It's hard to read. You need to simplify text. We're dealing with user interfaces that have both 2D and 3D elements combined with them, which is very common. So over here we have this kind of number wheel that shows as it moves from 0 to 1 as this lever is moving. So a 3D element mixed in our UI. And we have more complicated hand interactions. So, I mean, VR is kind of the only medium right now where you have these controllers that kind of almost mimic the feeling of natural hand motion and grabbing. So now we have to deal with, okay, we were taught how to do ray casting and how to decipher where I'm pointing into the world based on a mouse position on the screen. But now we have these controllers in the virtual world in a 3D position. And so how do we do ray casting from the hands? So where is the user in VR? Where are they pointing at with their hand controllers? And this is what they're interested in interacting with. Once we deal with kind of ray casting off the hands and maybe interacting with some user interface elements with just kind of a clicking or a ray casting, we then are going to move on to some more in-depth hand interactions, dealing with pulling levers, and we'll show off a button. The buttons were kind of before the levers, but the buttons worked well on Rift, but then they didn't work well in Quest. And I don't know if maybe we were using this kind of first generation prototype for the Quest, these Santa Cruz prototypes, I think they were called. And for some reason, the colliders on the buttons just were not working well, so we switched everything over to levers. But interacting with buttons and levers now kind of lets us talk about, we have these colliders on the hands, we have these colliders on these 3D models out in the world that are acting as our 3D user interface. How do we deal with them pulling and moving, and at what states do they actually, switch states or indicate that some type of action was directed by the user onto this 3D object. And then we also have to deal with the grabbable script. Um, so the fact that you can pick up and walk with items or hold them in your hand. And so that's a lot of information right there. So we'll cover all this, and I think this will give the high school teachers a lot of grounding, and they're going to have to absorb it for a year. It's a high learning curve not only for 3D but now for VR, and now we're looking to make another set of curriculum in AR. So we're going to have to move a step at a time, and let it actually absorb with the teachers. So there was one more aspect with. Well, yeah, I'm gonna have to go. The previous video went through the prefabs and Oculus, the hands and the cameras, but I'm gonna have to go through the scripts a little bit more in depth. Testing and Rift. So this project is being built for the Quest, um, but I'm testing very quickly on the Rift. So most of the high school teachers are just going to be building on the Rift, but it seems like a few of them are going to be jumping into Oculus Go projects or mobile VR projects pretty quickly. And so this type of project setup is good because it works in the Rift, and I use the Rift for quick testing for playing in the editor, and then I'll build to the Quest because it's a longer iteration, it's a longer time to actually test. I have to sit there and build and go and put on the Quest and test if everything works well. When that's just wasted time. If something is wrong, you got to go back into Unity or whatever your development environment is and fix it. So not only do I do quick testing with this type of low fidelity models using this Pro Builder asset in Unity, but we also do very quick testing right on the Rift, right on the desktop, and mimic or emulate what it's going to be like on standalone VR, or in this case, Quest, or if you're going to do mobile, like Gear VR Go. You try to emulate as much of that experience as you can on the desktop to kind of minimize this downtime in your development. So that actually was a good overall. I'm going to jump back to the website. So actually, that is basically going to be the gist of what this will be. So you see here, like Sprint 1 is user experience, Sprint 2 is 3D user interfaces, Sprint 3 advanced hand interactions, and Sprint 4 is do your own project. And somewhere I might modify this a little bit because now I was talking about a lot about this low fidelity testing. Like now I have to introduce this idea of Pro Builder in Unity and just a very light modeling workflow. So I'll see if this changes things. But for now, that's where we are here at part 2. And if I click on Sprint 1, this video I'm currently creating, I think I'm going to put right here. If you notice, I kind of put my little advisory up here again. Sprint 1, kind of like this is an understanding with the teachers of why we're where we're at and what's the most use for them right now. Is this type of curriculum directed more toward the teachers? And in that regards, here's some readings that our resident professor who teaches user experience for AR and VR. These are the readings that were suggested. And this top one, the UX of VR, is kind of houses all of. If I click on it quick, just a warehouse of videos that was super useful when I was in the industry with virtual reality development. And so anyway, here's like a catalog of readings. Again, there's no textbooks. Everything's kind of still to be settled. What are the best practices in the industry? But at least these are the kind of the cutting edge or the best ones that are out at the moment. So these are for the high school teachers to read, get an understanding of. And these videos, some of the Elizabeth teachers came in for a day of training, and so it's like getting them it's basically like how to be a VR user. So how to use the Rift, how to set it up, how to put it on, how to set up the boundary space, do your sensors, hygiene, disposable masks, how to just function in VR, play some apps, be functional just as a user. And then I put them in the Quest as well for them to kind of see what standalone is looking like. And then I went through installing the Oculus SDK in a Unity project, talking about some of the prefabs, the local avatar that kind of has everything pieced together, the camera and the hands and body, and then doing a sample scene, kind of knocking down cubes and what have you. So I think this is a good part one or sprint one, like just how to be a VR user so that you, the teacher, can then teach your students how to function within virtual reality, um, first as a user and then as a designer or developer. So again, this is where these readings will come in useful. Usually, I found really interesting class projects at this phase is to use a bunch of apps. That means kind of like your school system or your school will have to buy some apps on the Oculus Store or Steam. Um, and then as you use them, maybe some educational ones, some entertainment ones, some type of simulations, some type of games, or anything that you get your hands on, try to expose a wide of a venue. Maybe even move off a desktop. Maybe do some mobile VR. See how it changes the graphics, the rendering, the handsets, um, and then start to not only be a consumer of the products of the software, but then try to turn around and think about why the design decisions were made. What was good? What was bad? What did you like? What did you not like? This can turn into a lot of writing exercises for the students. This was very similar to the beginning of the intro to 3D dev class. Like use a paint program and just try to do a simple task like draw an animal, and then break apart your workflow. What were the steps you were taking? What were the tools? What was quick and easy to use? What had a bit of an overhead you didn't understand and it took you a few tries to get to? Where were the failure points? Where were things very seamless? And then that introduces us to the topics of user flows and thinking as a user experience designer, which helps you to piece together, well, what do you want to make in a simplified, smaller version, and then moving into the development phase of it. So following that same fashion, that same process, here we have part one is really how to be a user and how to train your students how to be users and how to decompose um, experiences or applications as more of like a super user, an advanced user, and kind of crossing that threshold into being a designer. And that will lead into kind of that sprint two, where we might talk more about user interfaces or low fidelity prototyping, and leading into kind of advanced hand interaction.